Here we go. Week 4, Monday, February 3rd. Introduction to networks. We did a little review work on the TCP, IP, and OSI models. Actually, we kind of did it like a review session or a quiz type thing where I asked them to do some work. We took a brief look at Wireshark and see how that protocol analyzer, we did that. We covered initial network design ideas and talked a little bit about media, and then the last 35 minutes was dedicated to finishing up the assessment, or taking the assessment over modules 1 through 3. Let's take a look at what actually we spent some time, talked about access to the internet, specifics, IP addresses, and we talked about an IP, they talked about subnet mask, default gateway, DNS, and also MAC address. Even though we don't configure directly the MAC address, you still need that to communicate through the switch. We asked, where do these fall into our categories down here? So a packet, that would be at layer 3, where we talked about IP addressing, that would be the network layer. A frame would be at layer 2. Maybe I should draw this. And the packet would be right here. Okay? And then a segment, that would be at the transport layer. So as our data comes down through the OSI model, it gets broken into parts at the transport layer, and we create a segment, and then we encapsulate it with an IP address. Then it's called a packet, and then we encapsulate it again if you're using Ethernet with a MAC address, and then it becomes a frame, and then we put it on our medium, where wireless, or fiber. So these, a browser, so if we were going back here, a browser really would be up here somewhere at the top of the model, and these would really all be down here at the bottom of the model. We talked a little bit about the TCP IP, so these three up here, application, presentation, and session layers would all be just the application layer at using the TCP IP model. The transport layer would still be the transport layer. The network layer would be the internet layer. And then we mentioned the last two layers combined together would be network access. How do we access the network? Okay. So let's look at some more things that we talked about. Here we go. So we have here, we talked a little bit about our environment. So we have this logical diagram. I like to call this a logical diagram. If a physical diagram would be much more specific about where the patch panels and rooms and so forth. Now some people will say this becomes more of a physical diagram with the addresses, but I wouldn't say so. We're going to call it logical. So we have some IP addressing. We talked about the firewall, and so we have devices here in our network here, and then the DMZ, and where we had our devices on the other day for the network, and all those switches. And what we did over there then was I wanted them to capture the students. They did a capture of their configuration, and they created a document to where they're going to start accumulating configurations. And we wanted it in text form. So, and then they resubmitted that. Over on this end, we talked a little bit about connecting in right through the switch, and we practiced some pinging. We pinged some addresses here and here. Then we opened up Wireshark, and we used Wireshark. We had Wireshark connected off this main device, and we could see all the traffic going through. And we were able to see then the pings from devices down here to either this default gateway or one of these two interfaces up here. And those pings should work, right? They should work there because we're not actually going through the firewall. You might have a firewall on your PC that you'd have to disable, but then you should have been able to ping those devices. And then we were able to look at that traffic using Wireshark, analyze the traffic. We talked a little bit about the different layers in terms of out here on the internet, packets getting routed, okay? And we talked about our access in, Iowa Communications Network as an example, and then we talked about an ISP connecting in there. We'll talk a little more about that here. Oh, we can talk about it right now. We have a provider, we have a WAN connection. Now, depends on, we used a cable example, cable modem connected to wireless router, so somewhere is the responsibility here. So if, like in our house, the cable modem is owned by Mediacom, so they're responsible for this connection. We're responsible for anything inside, anywhere after the cable modem, like our wireless router and our connections in our house. Okay? So we talked about a point of presence between your provider and your network internally. So here's our point of presence. Okay? So we have this scenario where this connects to the main campus and then also connects to our area here on campus. And we're responsible for all that. The ICN is responsible for the signal on the other side of that. Then when you physically design that, there's some certain rules you should follow. We're going to talk briefly about some of those rules when configuring. First of all, there's a physical connection. You know, in the classroom we talked about RJ45 connectors, in which we connect wire to the network interface card in the PC, and that communication, and then those 8 wires that are in there. More of that on Wednesday. Some form of encoding. The information is encoded, like using Manchester encoding, and then signals. How does that coding represent ones and zeros? And what do we send across? Wire, wireless, or fiber. And we go into the details of those on Wednesday. Now, how fast these send? Well, your NIC on your device, okay, can send up to a certain speed of bits per second. And we'll look at some examples of that. And then what you're connected to, the switch. That ports on the switch will have a certain bandwidth or bits per second. Now, as the traffic moves through, there will be some latency between switches and routers and so forth. It takes some time for the networking equipment, the intermediate equipment, to move it through. So the actual amount that gets pushed through is called throughput, which would be less than typically the bandwidth. Okay? The good put is the actual production traffic that gets pushed through. This would be the actual data that you need, your actual website or your download or your text or your email or whatever it might be. There is some traffic that's sent that's for management. Let me list that out, write it in another color. Traffic that is used to manage the network. And we'll take a look at a little bit of that also on Wednesday. Last thing we need to cover here. What is this diagram up here? So let's take a look at, you have some provider that you're going to connect to get some type of, let's say, WAN connections. So then we have the point of presence where we connect to them. And then in your facility, they typically have a main distribution facility that is used to distribute all the traffic out to intermediate distribution facilities. Now, off an intermediate distribution facility, you can create another intermediate distribution facility. But then that's it. You know, if you have a big building and this goes off to one part of the building, and then you split this to another part of the building, and then all of a sudden you want to put something in over here, you cannot connect that to another IDF. You can't have 3 IDFs in a row. You can only have 2. So this would have to either go back to this IDF or up to the main distribution facility. Now, can you break that rule and make it work? Absolutely, but you shouldn't. Okay, and you'll see in networks where people fudge on that rule. But for in here, we're going to stick with that. And then when we talk about the physical cabling, let's say we're talking about Cat5 cabling, which can be 100 meters. Typically, your horizontal runs would be 90 meters. The cables connecting to the equipment would be 6 meters. And the cables connecting to the devices, 4 meters. And these are what we call horizontal runs. So in the IDF, you might have a switch that would connect to maybe 20 or 30 or 40 computers in that particular area. Vertical runs are between wiring closets or between main distribution facilities and intermediate distribution facilities. Okay, and then to the POP, these are all called vertical runs. Thought of as vertical, and these are thought of as being horizontal runs. We'll review that again on Wednesday. So Wednesday, believe it or not, if we were to talk a little bit, okay, we're going to talk about all of this. We're going to talk about this design ideas. If you're going to design a network, how you have to be concerned for distance, what kind of environment it is, how you lay the design out, wiring closets, and so forth, and then figuring out what type of media that you're using, right? So we're going to talk a little more about the design, and then we'll talk about all those specifics about medium. We'll talk about cables, you know, the coaxial cable briefly. We'll talk about twisted pair, shielded and unshielded twisted pair. Okay. We'll talk about fiber. We'll take a look at fiber and how it connects, and then we'll talk about wireless, sending the signals through the air, and we'll talk about those specifics. So, figuring if things go smooth, we should really wrap up the chapter 4 or module that talks about the physical layer, and then we can start talking about number systems a week from Monday. So make sure you're keeping up in the materials packet tracers and materials, and the quizzes and the materials. That is it.